note we have a wide variety of skills and experience across the different elements in the mobile space. And so what's important here is that we want to try to ask questions, and while you're thinking here, you're sending us your tweets, if you will. Think about how security plays within these different spheres, because that's really where the challenge is. It's a layered approach, as we were mentioning, and because of those layers, each one matters, and it's the convergence of the infrastructure that we're focused on, the hardware platforms that we look at, the operating system, and ultimately the applications. We can't forget about the users, right? But if we can get at least to that part, we can put them in a position to not fail, to not put themselves in an interesting area. So before we had, we put out some feelers and asked them some questions. And I think the first thing we want to ask the panel is, how do you define the mobile device? So everybody here is probably, how many people have a smartphone in their pockets, right? How many people have a tablet, not to get any parties involved with it? How many people here have a reading electronic device? All right, and all of those could be on the cellular network, most likely on the Wi-Fi network, and they're all syncing to something magical. So we're all very much heavily invested in the space, and my clients in particular are very focused on distributed workforces and managing them, and then helping enable them to perform. So the balance of security has always been the cost-benefit analysis, the return on investment for to go into consumerization. And so with that lens, gentlemen, maybe Bill, you want to take the first one and define mobile device for us, and then maybe somebody can jump in.
Well, I think I'd go with E, all of the above. In that the mobile device it really truly is. It's the smartphones, it's the tablets. It can even be a traditional laptop with a wireless card in it. It could be a machine-to-machine device that's using cellular technology to connect some telemetry solution, or it could be e-readers or whatever. Because all of them are accessing data that resides somewhere. It's either local or remote, and there's a network connectivity, and they tend to be untethered more and more these days, because it's a more affordable way to deploy and manage those. So security needs to keep in mind all those different aspects when you're developing your applications that leverage mobility.
All right, so excellent framing. My question, I guess, maybe for Luccia, to give everybody a chance to jump in here, what is the radio we're speaking of? When we say mobile, are we talking about radio signals? Are we talking about cellular, Wi-Fi, Bluetooth, something else? So who's got a thought on that? Patrick, Vijay, gentlemen.
Sure. So when I teach my class on mobile security, I tend to define it as basically any device that can be untethered for more than 5 seconds and do something useful. But when I think about security in this space, that's not sufficient. And I'll just give you one example. When I run the Chrome browser, for example, on my desktop, I have all my web pages synced, and then I open the Chrome browser on my phone. Everything that I was browsing on one machine is now running on the other. So anything that was bad, that say I was silly enough to click on spam in one, now permeates to the other.
Vijay, you had a thought there?
So when we looked at mobile, the way we looked at it was, mobile is a way to combine communication with computing, and that's I think that's what smartphones graduated from with some feature phones, right? It suddenly allowed us to do computing anywhere, anytime. With that, so we were taking that, and if you work with that, we had an auto manufacturer in the U.S., and they said, we were talking about how they can improve internal efficiencies with mobile computing, et cetera, and they were like, how can we actually turn our cars into mobile devices? We want to have a more social engagement with our consumers beyond that transaction point of selling the car. And that suddenly became a mobile device. It was you can deliver applications, you can deliver capabilities, value-added services, but all of that needed to be secure as well, because they're connected. Once you're on the network, your mechanical systems and the cars now, a lot of it fly-by-wire type kind of technology. So you don't want to put people's lives at risk at the same time. So security becomes paramount, even in that context.
So what I would add there, to carry on Bill's comment about all the above, I would actually challenge what isn't mobile. And so one might define it as, well, if I can untether it, then it's mobile. But an observation I had today flying down from Northern Virginia, I was on, I guess I was at 20,000 feet, or however you fly, however high you fly. I don't know. And so, well, what interesting thing can I do on my phone? And there wasn't very much that I could do, short of maybe playing Angry Birds or Turbo Granny. If you ever haven't played that, try it out. It's a lot of fun. So I killed a few minutes playing that, but I was going through my apps, and I quickly realized that there wasn't really much I could do unless I signed on to the GoGo in-flight network. So if I'm required to be connected, not physically but virtually over a cellular radio, then what isn't mobile? Because I still need that thing on the other side. So you got to think about it as more maybe as a system. A system is the thing that I have in my hand, or the thing that's attached to a machine transmitting telemetry data, but it's talking to something else. And that needs to be part of the ecosystem that's considered here when we talk about mobile security. And mobile security is not just what's in the hand or what's in the device, it's that whole system. So when we think about it as the system, cloud computing and mobile go together very well, but it means that cloud computing is part of mobile as well. So we flip it around and say, what isn't mobile?
So a lot of times when I work with organizations, we try to define security, we try to consider the risk and risk management involved. And so when you hear these definitions, I imagine you're saying, okay, so in my enterprise, I have all of these things that are mobile, and a lot of them I don't control. So we have devices, in our automobiles, we have devices in our heart monitors. But then we have the simple fact of the matter is when we break down the mobile situation, we have, first off, an infrastructure, right? So we have a cellular infrastructure that we try to use. And if anybody here has ever gone to a conference or Braves game, you try to actually use the cellular network that you seem to be subscribing to. I don't mind any provider, and none of them work. So it's an interesting fact, and we are having so many mobile devices and so many radio broadcasting. There was research, and Patrick, you probably explain this better than I, where we're actually able to get nano devices to be able to function on the reverberations that those radio signals cause in a specific space, because there's so much radio signals happening. And I see a lot of customers actually have so many mobile devices that it's causing a denial of service in technology. Like the printers can't print because now they can't talk. And the payment services can't process payments because they're not connected. So let's talk about the infrastructure. And I guess number one, is it a risk that companies should deal with, and how would you deal with the risk at the infrastructure level? So you pay for a service, and you presume that will remain connected. As a business, is it a risk, and should it be addressed?
Can you clarify infrastructure? Do you mean the mobile network
Yeah, let's
infrastructure?
talk about the mobile network. Let's speak CDMA,
Not the
GSM.
cloud, not the...
No, we're talking, end device in space. It's talking to, we're paying an AT&T provider.
So if you're talking cellular, I think that's probably the least of your concerns. Because of all the encryption on the airwaves and in the network, and the ability for them to potentially
We're good. No mind there.
for someone to be able to intercept that data stream over a mobile network and do something with it, the odds of that of happening are slim to none, because of the complex technology and the amount of it you would need, and to be in the right place at the right time to intercept it. So I don't see the infrastructure. While you need to be mindful of it, I don't think the infrastructure from a cellular standpoint is your biggest concern.
So recognize it, but it's
That's not your weakest link.
all right. So what is your weakest link?
The weakest link is always the user.
Oh, okay. Yes, you're going there right away, aren't you? Stop saving that one.
So I'm gonna push back a little bit just to maybe start a little controversy. So in the context of, let's say, 2G networks, GSM was the most widely deployed, arguably communications technology on the planet. I mean, if I told you the internet was a big deal, At 1.5 billion users, you'd all say, yeah, Patrick, I agree. Cellular has 5 billion. So first, how do you do business without that infrastructure, especially on a global scale? I don't know. The second is, there's a chaos club in Germany that sells a backpack. And the backpack basically takes apart the core encryption of GSM and allows you to listen into and potentially intercept anything that happens to go over the air. And additionally, there are a number of attacks against 3G networks where you can convince users' phones to say, you know what, 3G is really not available. Let me go back to the less secure GSM standard, and then you can use this product to intercept. Why is that a big deal? And let's put it in the context of mobile money. If I'm doing mobile money from my phone in a place like Nairobi, and I'm on a 2G network, and I can intercept everything, that's protected by a PIN. Right? It's an unencrypted channel. You can potentially intercept that. So while I tend to agree, I mean, listen, actually intercepting, getting the right shipping codes, getting everything right on a 3G network is hard. There's enough legacy stuff out there, and there are enough ways to force devices to go back to it that saying, don't worry about SSL if you're on cellular, is not something that I would agree to.
So one topic we
Respond to that.
You're allowed to do
Actually, I
that.
don't disagree with the points, but I guess it's a relative statement, because I'm thinking more of these technologies and the more advanced applications and smartphones, they're really leveraging 3G, 4G technologies. That doesn't mean you don't consider things like SSL and other layers and multi-factor authentications. You have to take a holistic end-to-end approach to this.
And what's fun is we're talking at 3G and everybody's using their phone, 4G, or they're going to get the latest, right? Maybe 5G someday. It's important to recognize that these mobile devices have radios on them that can go down in versions. And so much like in the SSL browser space, where in some countries they restrict the cryptography that's working in those spaces so that the government literally can decrypt the traffic on a faster basis. In the mobile devices, smartphones specifically, you will notice, so for instance, if you were with AT&T or Verizon, if you were to use data, the cellular voice would it not switch to a different band? I believe that's the Verizon switches bands. Is that right?
We're simultaneous.
That's beautiful. So it's important to know. This is a team effort here. So let's jump right into the application layer. Let's talk about malware. Let's talk about the risk, and at some point, I'd like us to bring us home and understand what's the solution that exists today. Is it at the enterprise level? Is it single sign-on? Is it convergence of applications or credentials? Is it UDID? So let's think about that layer for a minute.
Yeah, so from an application standpoint, I think the most important thing organizations to look at is that the earliest point of injecting security is during design, development, and test phase, right? Once the application's out in the wild, if you detect any flaws, bringing it back in and addressing that is expensive. The other thing to note is that in mobile, the people who are building these applications, mobile app developers, they're not as security savvy or security aware as even IT or systems developers. We complain about them, right? So how do you assist them in their development process to incorporate security? Something simple as encrypting the data that an application stores on the device is something that needs to be enforced with greater standardization.
So is that something that enterprises should do, or is that something that exists?
I think it exists, but people don't do it. And
The consumer or the enterprise?
The application developer. So the application developer could be the consumer apps that you see on the app stores, or it could be applications that enterprises build for internal consumption as well.
So the average device, if you were to manage that that's ever published, is roughly 100 apps per mobile device. I don't think the onus can be on the user to or the enterprise to contain that.
It's the app developer who can incorporate encryption of the data, right? It's not while they're building the app, and that's the end user. They wouldn't even understand if.
So you're talking about a chaining of trust that is broken in the beginning.
Exactly.
Other people have any thoughts there?
Yeah, to carry that on, when somebody mentioned the user is the most insecure, right after that is absolutely the developer. The developer mindset is, I've got a job X to do, and I'm going to go do X, and that's what I need to get done. And you're absolutely right. Security's got to be in there from the get-go. You know, it's simple things like, again, this panel I was at last night, it was on mobile security, so it means maybe it's the topic of the day. But you know, somebody introduced SQL Cipher, bit of technology to secure your data in a database on a mobile device. Well adopted, well defended from a black hat perspective, but the presenter in the room, or very few people but the presenter in the room, knew that it existed and how easy it was to use. So the mindset, again, is for the developers to sit down and just get the job done and not worry, and we'll worry about security later. I had a developer at one point in my career would always, let's get it to work and then we'll get it to work fast, and then we'll secure it. And we never seem to kind of get to that third step sometimes. And so I think that chain of trust is a nice way to kind of phrase that. Because the user is just expecting it to do the right thing, not knowing that the developer didn't take the time to do some very simple things. The one thing that I'll counter is on the Apple side, you've got Apple trying to provide really easy techniques to encrypt the data both in transit and at rest. The idea being there that if everybody uses these simple techniques, then all the data is secure. And there's a lot of value in that on the consumer side, but on the enterprise side, the issue with it is when that the crux of that security is broken, it's broken all the way around. And that's really the fundamental problem with sort of that keychain mentality. So having something that uses standard technology like the SQL Cipher to encrypt that in a very standard and strict way is important, but changing it enough so that you're not sort of signing up to doing security the way that everyone else does it, because that leaves you vulnerable to the same attack that's discovered for application A, and your application B, you're vulnerable to that same attack. So
that's interesting.